Okay, in this video, we're going to be solving some exponential equations. Now, we have done some exponential equations already, and then let's remind you of what those look like with this warm-up. Again, warm-up is using a common base to solve exponential equations. So, like with this problem, we have 5 to a power equals 25. Well, what we can actually do is we can rewrite that 25 also as 5 to a power. And anytime you have the same bases, you can just simply forget about those bases, set the powers equal to each other, and solve from there. So here n is equal to -8, done. And this is much quicker than the method we're going to be using today, but not all problems can be solved the way that these are. 9 and 27 are both base 3 numbers. 9 is 3 to the second. I'm going to rewrite that as 3 to the second times a plus 2. And then 27 we're going to rewrite as 3 to the third times, or to the 4a minus 2 power. Powers to powers, we're going to multiply. This would be 3 to the 2a plus 4 power. This would be 3 to the 12a minus 6 power. And now that we have the same bases, we can now simply set the exponents equal to each other and solve. Move the 2a over, you're now left with 10a. If you're going to move the a's on that side, move the 6 to the other side, and you find out that a must be 1. Now, today's lesson, again, we don't have that common base. It's not possible. So here's what we do. Step number 1, we're going to isolate our exponential expression. Step number 2, I like to do it differently. It says take the log of both sides. I like to do this. I like to just change forms. We're going to change it from an exponential form to a logarithmic form. Step number 3, you may need to expand the log by using the power rule. Then step number 4, we're going to solve and check for extraneous solutions. Rounded answers may not produce the exact same answer, but will be very close. Reminder that on these answers, the solutions may be like an irrational solution. So when you plug it back in, it's not going to be exact. Like here, once we solve for x, plug that thing back in. It's not going to give you exactly 61, but it's going to be really close. So here's your first example. Step number 1, we're going to isolate our exponential 2 to the x, and it's already isolated. Step number 2, again, I like to change forms. We're going to change this to a logarithmic form. This would be log base 2 of 61 is equal to x. And notice that when I do that, x is now solved for. However, how do we type this into our calculator? This is our change of base formula. We're going to type it in as the log of 61 divided by the log of 2, and that's going to tell us that x is approximately 5.9307. Number 2, and again, you can raise 2 to the 5.9307 power. It's not going to be exactly 61, but it's going to be really close because that is, again, a rounded answer. Number 2, again, step number 1, we're going to change forms. This will be log base 8 of 92 is equal to m minus 7. This can be typed into your calculator by doing the log of 92 divided by the log of 8, which is 2.71745. And again, on the other side, you still have is equal to m minus 7. The last step, we do have to move the minus 7 over by adding 7, so we get 9.1745 for our m. Number 5. Again, your first step is to actually isolate your exponential. So since this is being multiplied by 4, we will divide by 4 first. So you have 7 to the nth power is equal to 37. So 7 raised to what power is 37 is what we're looking for. And you can do 7 to the first, 7 to the second. You understand that, well, there's no power we can raise it to. However, that does tell us our answer is going to be between 1 and 2. From here down, we just simply change form. This is log base 7 of 37 is equal to n. This is typed straight into our calculator by doing the log of 37 divided by the log of 7, which is 1.8556, which is equal to n. And again, that is an approximate value. Now, if I were to ask you for an exact answer, this is your exact answer. You could stop there with an exact answer. Next one, we're going to again isolate our exponential. 4 to the 3w has a minus 5. Let's move that minus 5 over by adding 5. So you have 4 to a power equals to 8. And now on this one, I want to point out that we can actually write 4 and 8 both as base 2 numbers. So the best way to solve this would be 2 squared to the 3w equals 8 would be 2 to the third. So that'd be 2 to the 6w equals 2 to the third, set 6w equal to 3, and you get w as a half. But just to show you, you can still solve this the other way. This would be log base 4 of 8 is equal to 3w. When you type log base 4 of 8 into your calculator, you actually get 1.5 is equal to 3w. When you divide by 3, you get w equals 0.5, which is again the exact same answer we just got. So that one, anytime you can turn them into the same bases, please do so. It's much easier. Next one, we got two different things to get rid of. Step number one, let's get rid of this 7. And you now have negative 4 to the x plus 1 power equals 11 by when you subtract 7. Now, you actually have now a negative that you also have to get rid of. This negative is not being raised to the exponent of x plus 1. So therefore, let's move our negative over by dividing by negative 1. So you have 4 to the x plus 1 equals negative 11. Now, we could actually stop right here, and we know what our answer is, but I do want to go a little bit further just to show you. This would be log base 4 of negative 11 is equal to x plus 1, which you should already know the answer, but if you try to type this into your calculator, you get an error. And the reason you get an error is because you cannot take the log of a negative. If you were to go back up to this step, you cannot raise a 4 to any power to give you a negative answer, because even if you were to raise 4 to a negative power, that brings it to the bottom, and that would be 1 over 4 to the second. That's still a positive value. Exponential functions like this, unless it's been translated down, will never equal a negative value because it has an asymptote line at y equals 0. So therefore, this one will be no solution. Number 8, first step, let's divide by this 10. Gives you 5 to the 3k minus 3 is equal to 4. Now we can simply change forms. Log base 5 of 4 is equal to 3k minus 3. You're going to type this in by doing the log of 4 divided by the log of 5, and that's going to equal 0.8614 is equal to 3k minus 3. Next step, we've got to add the 3, so you have now 3.8614 is equal to 3k. Then the last step, we're going to divide by 3, and we find out that k is equal to 1.2871. Number 9. Again, isolate your exponential first. Get rid of plus 15 by subtracting 15, and you now have 4 times 3 to the nth is equal to 344. We now get rid of the 4 by dividing by 4, and it gives us 3 to the nth power is equal to 86. So now I know 3 to the 4th is 81, so that's really close. So it's going to be a little bit bigger than 4. To figure out what that n is going to equal, we're going to do log base 3 of 86 is equal to n. We type this in by doing the log of 86 divided by the log of 3, and that tells me that n is approximately 4.0545. And again, log of 86 divided by log of 3 is how you type it in. Next problem, isolate the 5 to the p. Let's get rid of plus 7 by subtracting it. So that gives me negative 2 times 5 to the p is equal to negative 70. Divide by the negative 2 gives me 5 to the p power is equal to 35. A lot of people would make the mistake here by putting 7. That is incorrect. That's 5 times 7 is 35, but you're saying 5 to what power? So we're going to do the log base 5 of 35 is equal to p. Then you simply type into your calculator as the log of 35 divided by log of p, or log of 35 divided by log of 5, which is 2.2091. That is your approximation p. The next one. Let's again isolate our 9 to a power by getting rid of plus 1, and then we can go ahead and divide by 5 in the same step if you would like to. Subtract 1 divided by 5 gives you 36. Let's change forms. This will be log base 9 of 36 is equal to v minus 1. This can be typed straight into your calculator again by doing the log of 36 divided by the log of 9. And that gives you 1.6309 approximately equals v minus 1. Last step, get rid of minus 1 by adding it, gives you 2.6309 is equal to v. Number 12. Get rid of minus 3 by adding it, gives you 8 times 11 to the 7k power equals 216. We now divide by 8, gives you 11 to the 7k is equal to 27. Rewrite it. This would be log base 11 of 27 is equal to 7k. We again type this into our calculator by doing the log of 27 divided by the log of 11. And that gives you 1.3745 is equal to 7k. Last step, let's get rid of the 7 by dividing by 7. And you get k should be about 0.1964. Number 13. Get rid of the minus 2 and the times 6. Again, we're going to first, let me write this down. We're going to add 2. That gives you 84. And then divide by the 6 gives you a 14. We know that 16 to the first is 16, so therefore our power here is going to be a little bit less than 1. This would be log base 16 of 14 is equal to the 7y plus 2. Log of 14 divided by the log of 16 would give you 0.9518 is equal to 7y plus 2. We now get rid of plus 2 by subtracting 2, and we get negative 1.0482. And then last step, we've got to get rid of the 7 by dividing by 7, and we get a final answer of negative 0.1497. The next one, number 14. Step number 1, again, isolate your exponential. Let's subtract 10, gives you 3 times 8 to the 3 minus 7n is equal to 84. We now divide by 3, gives you 8 to the 3 minus 7n is equal to 28. Next step, rewrite it. Log base 8 of 28 is equal to 3 minus 7n, and this can be typed into our calculator. Log of 28 divided by the log of 8 is 1.6025, and again, that's 3 minus 7n. Next step, we've got to get rid of 3 by subtracting 3, so we're going to do minus 3 there, and we get negative 1.3975, and that's equal to negative 7n. Last step, divide by negative 7, and you get n as approximately 0.1996.